Alright, hello and welcome to my physically based rendering, real render to texture, and diegetic asset stream. This is going to be, for the most part, an educational stream or just sort of an informative stream. So I do have my webcam turned off, so I'm not in the way, and I have my alerts turned off. So none of the following notifications or any of that stuff is going to pop up during this. I will try to get through bigger blocks of information before addressing any questions if they do pop up, but I will try to keep my eye on any questions that are pertinent to the discussion or the subject at hand as I'm moving through subjects, which will tackle PBR or physically based rendering first, and then we'll move on to render to texture and tie that into diegetic assets and UI assets as well, because those are sort of piggyback off each other. So this is sort of born out of a desire to put some more information out there. Not that there isn't there's information out there on this already, but I thought I would just continue to add to the data available, because there's a lot of discussion around, especially in Twitch and around other game development Discord channels and discussions about these particular topics in game development, and it seems to be a fair amount of people who are not necessarily it's not necessarily their fault that they're getting some of this stuff wrong. These are sort of somewhat complex technologies and terms to sort of use correctly. But the more people know about this stuff, the better. And the more they know about this stuff and the more information on these topics is out there, the more people can appreciate the really hard work that a lot of game developers are putting together for the consumers and the gamers. There are a few game companies out there that really stand out in this area, like CIG Games and Guerrilla Games are a couple that are really pushing the boundaries of what you can do with the current rendering technologies and methods used. And that's where I sort of see most of this disparity in general information on these topics flowing from in discussions of game development around these couple different games. But so we'll just go ahead and get into the data part of this and get started. So we're going to be tackling physically based rendering first, and physically based rendering is what you're looking at right now. This is a physically based rendering engine. This is Unity, and ever since Unity 5 it has been a physically based renderer. And physically based renderers are like in Unity and CryEngine and Lumberyard and Unreal. And what physically based rendering means essentially is that it is a renderer, which is the part of the engine that actually generates the visuals you're looking at, that creates the on-screen visualization of the 3D assets and the lighting and all the stuff that you put into the environment that you want to play in. And physically based rendering is a render engine that is built to get closer to mimicking true life or real life representation of materials and lighting as it flows through an environment. So a couple of the core components of physically based rendering is built-in global illumination and reflections, which help create the atmospheric mood of sort of real life and visualization of more true to real sort of assets, because pretty much everything reflects something and light bounces off of almost everything. So global illumination and basic reflections add a lot and give you a lot of cool things to play with inside of a rendering environment. So one of the things to notice first will be the reflections, and they begin automatically and they vary depending on the material type you're working with. So aside from the lighting and reflection, global illumination and reflection part of physically based rendering, which is automatic, so anything you put into an environment like this is rendered on a physically based basis. Any asset that you put into a physically based rendering environment is automatically a PBR asset, as it were. But what really makes materials and assets actually inside of a physically based rendering environment stand out are the physically based rendering materials that you use, which operate off of a few different inputs. There can be a lot, but the ones that make the most importance are the albedo or the color map, the metallic map, smoothness or roughness. It's smoothness in Unity, it's typically roughness in Crytek or CryEngine, Lumberyard, and Unreal, and your normal map. Diffuse or albedo and normal map should be pretty familiar to people. Albedo is just the basic color information, so if you change it around, you can change colors. A normal map adds bump and relief based on a two-dimensional image that is typically gathered from a high poly resource or a high poly source mesh. What makes PBR stand out and be truly different from other rendering engine types with its material setup is the metallic and the roughness. And these are image inputs that assign material type and reflectivity, which is sort of a combination. In PBR, reflectivity is kind of a combo of reflection and specularity. Your metallic map is a grayscale image. It can go from pure black to full white. If it's pure black, that means that the item that you're attaching this to is a non-metallic item, like cloth. If it's full white, that means that you want your material to be a fully metallic object, like chrome. And you can go in between. Because there's room for grayscale in between all of that to create different effects. And then, in addition to that, typically what's nested in the alpha channel of your metallic map, which is right here, if we go to our alpha channel, is your smoothness or roughness map. In Unity, it's smoothness, and what white means is full smooth, which is like a mirror finish, and black would be zero smooth, which would be dirt, or maybe even like cloth again. You have almost no reflectivity and no light bounce off of it. And of course, you can go anywhere in the grayscale between those two. If you're working in Crytek, Lumberyard, or Unreal, it's roughness. So full white is full roughness, which would be dirt, and black would be no roughness, which would be smooth. So depending on what engine you're in, there may be a little bit of a disparity between what those values mean, but it's pretty much either an inverse of one or the other. So this first material we have here, as a general example, this is a non-metallic, fully smooth material. So as you can see, it has full reflections. You get pretty much a mirror finish, but it's not a metallic object, so it doesn't have some of the features that metal would have. It's a bit more, you can sort of, even though it's got a high sheen on it, it's more like a really reflective plastic or glass. This would be a good glass reflection. And if you wanted to be transparent, you can add a little bit of alpha to it, and that's not working right now. But we'll have an alpha one over here we can adjust. And then as you move down the line here, this is non-metallic with 50% smooth, which you can see if you go to the half smooth alpha channel, it's gray instead of white. So it's got some reflection. You can sort of see the light, a bit of the highlight here, and it's picking up. There's little subtle things you can see in here. And then this one is non-metallic and zero smoothness. So this one doesn't reflect almost at all, which you don't really want to operate in extremes, because most things in reality reflect light to some degree. So a full zero smoothness would probably not be real. Neither would almost a total full. Most things don't exist in extremes. Then we can move behind here, and this row is the metallic materials. So this is full metallic and full smoothness. So the light is highly reflective, and this would be something like chrome as far as its level of metalness is kind of how it's described. This one is the full metal half smoothness. So you can sort of see, if you move the camera around, you can begin to sort of see the white is reflected in here, and it reflects a bit more than its non-metal counterpart because of its metallic value. So these two spheres here and here, this one and this one, have the same smoothness level, but since this is a metallic material, you're going to get more reflection based off of even the same smoothness, because the material type has its own properties that add to that. And then this, of course, is metallic and zero smoothness. So this would be a very flat metal. And then over here we have our transparent material, and this one has about a 50% opacity on it, and currently this is a non-metallic with full smoothness, so this would be like glass. Now if you wanted to make it fully metallic and fully smooth, what happens is that full metallic at all, it loses its transparency, because the system sort of doesn't break, but it sort of restricts you and says, if something is fully metallic, then it's not going to be transparent. So if you want to have transparency, your object cannot be fully metallic, because then it won't work, because most full metal is not transparent, and the physically based renderer understands that and works within those particular parameters. So those are basic material setups, and then you can get way more complex if you want. There's lots of room for all kinds of amazing detail you can put in. And what I just opened up here is a folder full of substances that I've made in a program called Substance Designer, and it's a procedurally based, physically based rendering material creation program, and it's really awesome. If by any chance no one is familiar with it, it is a supremely powerful program, and it lets you create really good tools and materials. And let's pick one that's got a good variation. So this is a sort of swampy, dirty, muddy ground terrain with some water in it, and it's got your basic diffuse metallic map, normal map. This one has a height map and an occlusion map to add a little bit more detail, but you can even turn those off just to sort of get. You'll see the height map helps a little bit. There's some camera effects. But if we remove those, and then it's just down to then it's back to normal map, color map, and height, or color map and metallic and roughness. And we look at the metallic one. Here's the metallic image for it, which we'll pull up here. So it adds a little bit of a metallic material to the water, not full, but just a little bit to sort of add to those really strong reflections. And then where the dirt in the ground is, you can see is fully black, which is non-metallic, because dirt and ground is not metallic. And if you go to your smoothness map, it's got, again, strong full white for the water to get full reflections, and pretty much black for the dirt. And you can see there's some little bit of gray areas around where the water meets the dirt at the shoreline. There's some different areas of gray in here to have some variation, but you get really strong reflections. You can see the clouds and the water, which makes really nice material separation, and you get all this from one material using this metallic map to really draw out some of the differences, and you can see it when you pass over it. So if you're playing, if you're walking around in game, you get really nice, these materials stand out really strong, and it creates a good separation, which helps sell the visual quality and sort of the realism of the scene or the texture that you're making. And these can be really complex and really simple. You can have them for all kinds of different materials. Here's brass, and if we look at the brass metallic, see it's got a lot of variation, and then its roughness map there's a decent amount of variation in there, but there's not a whole lot of hue change, because again you're dealing with this is purely a brass material, so it's going to have mostly for the most part a pretty consistent material type over it. But you can see some of the striations in the metal coming from the information, the metallic, and the normal map pushing through. And the normal maps really help with physically based renderers. They react well to normal map information as far as breaking up the surface. You could do asphalt, which is a pretty basic material, but again, if you look at the metallic, the ground it's probably a bit high on the metallic level, but its roughness is pretty low. You could probably turn that metallic down a bit, because might be a bit shiny for asphalt. But sometimes in game development and game environments, you have to push values a little bit to sort of make them pop a bit more, so that you're sort of noticing the textures. Here's a nice matte sort of black plastic, or it would be also good for a rubber material. And if you look at the plastic metallic, it's about mid-range, and its roughness or its smoothness is almost all the way down, because rubber or plastic is not super reflective. So you can sort of tell that as you vary these values in your image maps, you get a lot of variation for your material types, and you can go from here to a nice metal. And again, there's most of this lighting information and material separation is coming from the metallic map and then the roughness map, sort of letting the engine renderer know where to create strong values and changes in material types. Another really good material is this snowy ground one. This one I did not make. There's a really cool resource called Substance Share. It's a website. If you're using a Substance Designer and you're not going to Substance Share, you are doing yourself no favors. People upload substances for other people to download and make use of, and they're really well made. A lot of them are really, really good and have a lot of really cool, powerful controls. It's going to tighten up this a little bit so you can see it a bit better. But then within this, you can actually create exposed controls and a lot of these material types that let you change things on the fly inside of the game engine itself, which is another really powerful tool for saving processing power while giving you a lot of different texture controls and being able to, you can affect these things in game in real time. So you can change levels. So you can actually change the snow amount by moving these sliders. And so if you wanted to go, show snow melting in game, you could actually just select these parameters and animate them over time. So Substance Designer is an extremely powerful tool you can do a lot with. But even in this one, if we look again, we'll look at the normal first. So where the sticks and the dirt is, it's very noisy. The snow is pretty simple, normal information. And then the metallic is almost all black because none of this is metal. So that's a really simple metallic texture. The roughness is a lot more varied because the snow, the ground, the dirt, and there's rocks in here. And if you get closer and look at this image map here, move this up here, you can sort of see where the edges of the snow are to create more highlights, kind of where the rocks begin, and all of this will, changes the way light affects it as it crosses the surface. So you can get these really nice material separations. Even within the same material and the same texture, you can have lots and lots of variance if you put the time in for your metallic and your roughness maps that go along with these materials inside of whatever physically based rendering engine you're using. So that's a pretty decent run through of what physically based rendering is. And this is just sort of a basic stream for terminology and understanding of what these things really are. So I won't be getting into any sort of detailed process on material creation or asset creation. We could probably do that in another stream and go through a lot of other stuff to sort of inform on how you make those things and how you set them up. But there's a lot of work you can do and a lot of detail you can make to sort of get things standing out and really looking solid. But physically based rendering covers the light as it goes across the surfaces, your metallic maps, your roughness maps. These really helps take advantage of what physically based rendering has to offer. Outside of normal maps and color maps or diffuse maps or albedo maps, or have been in game engines for a long time. So one of the biggest jumps for physically based rendering is as I mentioned in the beginning, the global illumination reflections that are already built in, and then the use of metallic and roughness maps really adds quite a lot. And I'll open up this here. This is a defibrillator that I made with physically based rendering, with a physically based rendering material and workflow, and it has some pretty good material separation that you can sort of check out because there's some smooth plastic here in the handles, and then the body of it is actually more hard plastic, so it sort of doesn't highlight as much, and then the actual screen itself reflects a bit more, not a huge amount, and then there's some plastic in here that picks up light when you go across it, and all this stuff is you got like a color map, which is pretty basic. Again, it's just the color information. Your bump map on this one is pretty basic because there wasn't a whole lot to do in here bump wise, but where it comes through in the metallic map, again, pretty basic because this is mostly a plastic object. But then in the roughness map, there's noise information, there's scratch details, separating stuff out so that these stickers on the side here are not the same, don't have the same sort of reflective smooth level as the plastic they're actually on. So there's just lots of stuff you can do to separate your materials out and make assets that look really nice inside of a physically based rendering environment. And that pretty much covers physically based rendering for just the basics. So as a quick recap, physically based rendering is a rendering technology that better models the way light flows through an environment, has global illumination and reflections, and then lets you fine-tune and the assets inside of this environment using metallic and roughness maps. Metallic maps decide what type of material your object is, whether it's a metal object or non-metal, and the gray areas in between those values on a metallic map uh, sort of change that up. It's not specifically only metal or not metal. Those can be moved around to represent like different types of differing levels of plastics or glass. You can sort of mess with metallic values. And then roughness or smoothness is how reflective the surface is, and how much light bounces from it or off of it. Like for this one, if we adjust the smoothness here, you can sort of see how that changes pretty quick. Um, and then if we had a map in here, it would alter quite a lot. So, but that's pretty basic physically based rendering and physically based rendering materials for how games use them and how they function. The next section, I'm going to open up some more stuff in this environment to cover real-time render to texture and diegetic assets. So there's a bunch of stuff I'm going to bring in. So just take a quick second to get all of it in for this to pop up. So there's a lot of assets in here, so it's going to take a second for it to sort of populate. But render to texture is a very cool thing that is being used a lot. It's been in games for a long time, but it's being used more now because games can process more, which gives them more options in how they can sort of send camera information and texture information places. I just got to get to where my scene is. And this will be a basic scene setup. This environment was built from the Atom demo assets that are available in the Unity store for free. I wanted to put some stuff together just for the environment to have some variance and something to look at in reference to how this is all set up. So one of the things that's been talked about pretty recently, especially with Gamescom recently, and some of the stuff that Star Citizen's been doing, pushing the envelope of sort of what you can do in games tech-wise, is render to texture. And render to texture is a really cool thing that you can do. Like I said, it's been done in games for a long time. Half-Life 2 had render to texture stuff in it, but what it basically does is it takes a game camera's view and creates it into a two-dimensional image that you can then place anywhere in the game world as a texture, and it updates in real time, so that you can put people talking on video screens. And Star Citizen or CIG is currently using some really cool techniques with their render to texture to also create holographic images that are three-dimensional. I won't try to delve into how they're doing that, but they're working within the render to texture sort of pipeline to do that, and this will be a basic explanation of render to texture in general. So this plane right here, it has a render to texture material on it, and let me select it real quick. My mouse is acting a little funny. So right here is the render result, and this is a render to texture image that is being captured by a second game camera in the scene, which is this camera. Make these 3D icons a bit bigger. Okay, so we zoom in here. This camera is looking down at this scene. This camera is the player camera. So if we look at the actual game, that camera is what the player would see. And then this is the render to texture camera, which looks from a different view. I can move it around anywhere I want. You can sort of see right there where that plane is updating with what the image is showing. But this has a render to texture target texture file on it, which is here in the hierarchy. And then this particular plane that's being shown has that texture that's created on it as a material. So anything that this camera sees will get projected as a two-dimensional image on whatever asset has that material on it. So if I felt so inclined, I could come in here and see here, where is that material? I'll just grab it from the plane. I could grab this material here, put it on that box, and now that box has, or this cube, has the render to texture result on all of its faces. So that texture can be placed anywhere in the scene, and which is a very cool and powerful feature with render to texture. So if you wanted to project a secondary camera's image onto multiple monitors for any particular reason, you're just instancing the same image result, which is a really fast and efficient way of being able to project multiple images at once. And is something that is being used in Star Citizen and a couple of their ATVs. They've shown it, but it gets used a lot in games, and anyone who's played a game has seen render to texture happen in action, whether they know it or not. And so, like, you can see this move here. So this captures this, and then the game camera looks into the world and can see what this render to texture result is. Now, one thing that's cool about render to texture results currently is that they go hand in hand to a certain degree with the use of what is referred to as diegetic game assets, which is mostly that term diegetic is mostly being used now in combination with UI elements. But a diegetic asset, sort of by definition, is an asset that is part of the action and not part of the background, which is a relatively vague way of explaining that a diegetic asset in a video game is an asset that exists inside the game world. It is not laid on top of the camera as a secondary screen. It is not a two-dimensional UI image that does not exist in 3D space inside the game world that you're currently in. So this particular little iPad knockoff asset I made is a diegetic asset because it exists inside the game world. You can move around it if you so choose, and you can also send information to that asset. So if you wanted to, you could select the screen here, and you could send the render to texture result to the screen, to this particular screen, and you would be able to see it in game. So you can see the render to texture result from the secondary camera above the player is being shown on this screen, and then we're having a bit of an inception sort of effect because you can see the secondary camera result being captured and projected, and so that'll go down sort of into infinity. But that also means that this particular asset is seen by any other game camera in the scene. So another player walking around viewing the game world from a game camera would see this image on this screen, and would be able to see it if you were using it as a player. So we could do a quick play real quick and launch this scene. I can show you an example of sort of how that looks. It may take a second just to sort of get everything ready. Alright, so the box is spinning just to sort of show update information. And now if I move around, so we see the box is spinning, and this iPad thing is just floating here, but it's part of the environment. And if I'm a player, or if there's any other players walking around and walk past this iPad, everyone's going to see this same image, which is a render to texture image being displayed from the camera which exists in this general vicinity, from this angle, looking down at this scene. And so if you're following any current game developments that are using in-game UI, or what they will refer to as diegetic UI, then you're walking around these assets in the game world, and all the players can see them for the most part. You can change settings so that that any particular UI component is only visible by the current player, but by default, any object that you place into a game environment is pretty much visible to any game camera. Lots of programming and setup can change those basic parameters, but anything you dump into a game environment exists in the game world and can be seen in the game world. And so I rendered a texture result, probably most recently from Gamescom, if anyone was following Star Citizen or Gamescom, but one of the most recent kind of neat and cool things that someone has done with render to texture was that the folks at CIG Games showed in Star Citizen that you can make a video phone call on their Mobi-Glass, their sort of holographic wristwatch UI element. And it's using render to texture. So the person making the call has a game camera pointed at them. That game camera is creating a render to texture image that is then projected as a material onto the UI of the person receiving the call, and they can see all the updates, like we're seeing this cube spin. And if we wanted to, say, grab that cube maybe and move it, you can see it updates in the render to texture output, just like you would if you were having a video call with another player. You would see their faces, their character's head move around or do whatever, and that would update on whatever UI element you were using that was projecting a render to texture result, and that would be projecting it on a diegetic asset, which would be the UI asset that exists inside the game world, because that's getting more popular, I would say, but there's still games that don't use diegetic UI, like Path of Exile, like your inventory screen or anything like that, in like in a Diablo 3 type game where it pops up as a two-dimensional image on top of the game world. That is a non-diegetic UI asset. Whereas if this screen was showing an interactive UI element where you could select your inventory or whatnot, this would be a diegetic UI asset, as it's a diegetic asset already because it exists inside the game world. And it can capture and be the end result for a render to texture image, which is being sent from another game camera, which is a render to texture camera, and you can move this camera, which will of course update the image on the screen, and you can rotate it around, you can make it look at whatever you want, and all that stuff updates here. And once this image is created, or the series of images being created, as I mentioned previously, you can send this image result to anything. So if we wanted to, like I said, we could put this on the cube that's spinning, and then let's see here. This might make just to push this, but then you should see, yeah, that cube gets really weird because its render to texture result is being changed as it's spinning. But we can do a lot of stuff with render to texture, and it can be a pretty powerful tool. But that's generally what render to texture is, and the diegetic asset itself being the phone, or this plane and this spinning cube. Those are all diegetic assets. And you could also project. I mean, the diegetic asset can have any material or any texture applied to it. So you can put a movie texture on it, which these objects have now, and if I hit spacebar, it'll play. And this is actually an animation that my 13-year-old little brother made. He's getting into Pivot Animator, so I think I would put it on here because it's funny. But you can, and then so since the render detect, since that is image is a movie file on an image, you can place it anywhere. And then if we wanted to further display render to texture stuff, we're actually going to need to end this and restart the scene to get that video to play again, because my script only covered the playing of it. But so this goes back here, and now let's do this for the camera. We'll grab this plane here and put the render result on him, so he sees this. But then on the screen we can put the movie back on there. And plane. Hang on, my inspector didn't pop up. Right, there we go. Pad, and get the video on the screen here, and then place the screen. Hang on, I'm in this. There we go. On the screen, and then this plane will get render result. And we just grab the camera again and move it back so we can see the iPad here. Just right there. There we go. And we'll play the scene again, and this will be sort of the culmination of render to texture diegetic asset breakdown for the basics. So once this, there we go. So the cube is spinning, see the environment we're in. So this phone, all these assets are diegetic because they exist inside of the game world. The information that's being shown on this phone screen can be UI information, it can be a still image, it can be the result of the rendered texture, which we've already seen. If we hit play, this guy's roaring, and over here the rendered texture camera is capturing that updated information because it exists inside the game world for the rendered texture camera to catch, and it sort of again creates an inception sort of effect with the repeated images of what the rendered texture camera is catching. But that's pretty much it for render to texture and diegetic assets. So render to texture creates a series of two-dimensional images that a game camera captures, and then they can be used as a texture on any surface in a game world. And a diegetic asset is just an asset that exists within the game world, being lit in real time and rendered in real time by the game engine. So this phone, this spinning cube, this plane, this entire environment, these are all diegetic assets, and the render to texture output can be placed on any of them, as we've seen. So when discussions are happening, when you're talking about render to texture, diegetic assets, and physically based rendering, after watching this video, this makes a bit more sense and has been explained a bit concisely. In the future, I may do more streams regarding these sort of technologies and sort of how they work, and can go into more further detail on processes for asset creation, material creation, game engine implementation, and sort of the detail of how these work. But I wanted to sort of just put this out there as a general overview of what these terms mean, and and give them some visual and real-time context for how they work, in addition to what some basic definitions and breakdowns for them are. So I appreciate you watching this video, and if you have any questions or any information you would like further, you can contact me on Twitch or look out for another stream. I probably will put this on YouTube and maybe some Q&A in there as well, and I may have some more in the future. So hopefully you found this informative, and thanks for stopping by and checking it out, and have a good one.